Welcome to the session on control structures. I am Modigari Narendra, working as assistant professor in Vigyan University, and today's session is on control structures. The topics to be covered today is sequential flow, conditional flow, and iteration flow. So why you need all these things? Assume that you have two vehicles, a bike and car, and if you want to go outside, which one you choose, the car or bike? It depends on the weather condition. If the weather is rainy, generally people prefer to go in a car. If the weather is clear, people prefer to go in bike because it's economical. Here you have two options and you are choosing one among them at any time. So whether to choose car or bike, it depends on this parameter. That parameter is called as the weather. In the same way, if you are developing a driverless car and if the car is about to reach a traffic signal and the driverless car is supposed to observe the traffic signals. If the traffic signal is red, the car is supposed to stop. If the traffic signal is red and yellow, the car is supposed to stop and it has to be ready for the next movement. If the traffic signal is green, the car need not to stop, it can continue moving. In the same way, the control structures will specify whether to execute certain set of instructions or not based on a specific condition. It specifies the direction of the program based on certain parameters and conditions. So we have three flows: sequential flow, conditional flow, and iteration flow. In sequential flow, the instructions will execute one after another, and in conditional flow, there are four statements: if statement, if else statement, else if later, and switch case. If you have only one option and whether to choose or leave it, then go with simple if else statement. If you have two options to choose, and you can go with the if else statement. If you have more than two options and if you want to choose one among them, then you can go with the either else if later or switch case. And there is one more flow called repetitive flow. If you want to execute the statements again and again and again, if you want to repeat some set of statements again and again and again, then generally we used to go with the repetitive flow. So there are three statements: first statement, while statement, and do while statement. If you know exactly how many number of times you would like to repeat, then go with the for loop. If you don't know exactly how many number of times you would like to repeat, then go with the while loop. And do while loop is similar to while loop, except that the do while loop will repeat at least once irrespective of whether the condition is satisfied or not. Let's discuss one after another. A sequential flow. As I discussed earlier, in sequential flow, all the instructions will execute one after another. For example, let us take a toll plaza. So toll plaza is an example for sequential flow, where the vehicles will move one after another. The vehicle that is coming out of the toll plaza, the flow depends on in which order the vehicles enter into the toll plaza. In the same way, the check-in system in airport also. So in programming also, when it is a sequential flow, what compiler will do is, the compiler will execute all the instructions one after another. No statement will be skipped. Here, there are 6 printf statements are there. All the printf statements will be executed one after another, and you will get output in exactly the same manner. Okay. Here the first printf statement will execute first. The first output is instruction 1. The second printf statement will execute next, and the output will be in instruction 2. So all these instructions will execute one after another. The order of the execution will depend on the order in which they are specified. No statements will be skipped. All the statement will execute. Second one, a condition flow. So in condition flow, you will have set of statement and you have some certain parameters. Whether to execute a block of statements or not, it depends on your parameter. If the parameter is satisfied, if the condition is satisfied, then only the set of statement will be executed. Otherwise, the set of statement will not be executed. So let's start with the simple if statement. Generally, we go with simple if statement if there is only one option to choose. Let's start with an example. Assume that you are working in office and you are feeling hungry. So what you will do? You will take a break, you will go for a cafeteria, and you will come back and you will do the remaining work. If you are not feeling hungry, what you will do? You will not go to the cafeteria, you will stay back there and you will finish the work. So here hungry is a parameter. So if you feel hungry, then go to the cafeteria. If you don't feel hungry, don't go to the cafeteria and do the work. This is syntax for a simple if statement. The simple if statement will have an expression. So what is an expression? An expression can be a simple expression like a plus b It can be a simple expression, or it can be a conditional expression like which is having the relational operators. So this is a conditional expression which is having the relational operators. Or it can be a composite expression. A composite expression can have more than one condition, like A is greater than B and A is less than C. So this is an example for composite expression. So the expression can be anything. It can be a simple expression, or it can be a conditional expression which involves relational operators, or it can be a composite expression which is having more than one condition. What compiler will do is, the compiler will evaluate this expression. So it evaluates this expression either to true or false. Only two options. Okay, it will the compiler evaluates this expression and it gives us the result either as true or false. All the non-zeros will be treated as true, and 0 will be treated as false. What compiler will do is, the compiler will take an expression, it will evaluate whether the expression is true or false. So what is true? If the result of this expression is non-zero, then it considered as true. If the result of this expression is 0, then it considered as false. So for example, let's take an example. If A plus B, so A plus B is an expression. Assume that the value of A is 2 and the value of B is 3, and 2 plus 3 becomes 5. So this statement will become if 5. So what is this 5? Whether it is a non-zero or 0? It is a non-zero. So it means the compiler will convert this statement as if true. This is how the compiler will evaluate the expressions. It will take an expression, it will evaluate the expression to either true or false. So for example, let's take one more expression. Let's take if A is greater than B. This A greater than B is also an expression. So assume that the value of A is 4 and the value of B is 3. 4 greater than 3? It's a relational operator. If 4 greater than 3 is true, so it results in true. So this is an example for conditional expression. If you want, you can use composite expression also. It is nothing but an expression which is having more than one condition. Let us say A is greater than B and A is greater than C. So this is an example for composite expression. Okay, so you can give any expression as part of the if statement here. Either you can give simple expression like this, A plus B, or you can give conditional expression like this, or you can give a composite expression which involves more than one condition. So what happened? So what compiler will do is, the compiler will evaluate the expression. If the expression becomes true, then the statements you specified in if block will be executed. If the expression evaluates to false, and this statement will not be executed, and this statement will be skipped. If the expression is true, then only this statement will be executed. If the expression is false, this statement will not be executed, okay, and the remaining statements after the if block will be executed, and then the program will exit. Let's talk with an example. Let's print the biggest of two given numbers, let's say A and B. So what you want to do? You can use simple if statement. If A is greater than B, then you have to print A as bigger. If A is less than B, you have to print B as bigger. If both are same, then you have to print both are same. So this is the way how you are supposed to use simple if statements. Okay, here this is an expression. So this is an expression, this is an expression, and this is an expression. If this expression becomes true, this statement will be printed. If this expression is true, and the second printf statement will execute. If this statement is true, then third printf statement will be executed. Okay. All three statements will not execute all the times. It depends on the parameter. Now the parameter is this expression. Okay. If it is true, then execute this expression. If it is a true, execute this expression. Let's talk one more example. You have to print even if the number is an even number. So what you have to do? Get a number, check whether a number is even number or not. So when you can say a number is even number? A number is even number if it is divisible by 2 and the remainder should be 0. Okay? If a number is divisible by 2 and the number is divided by 2 and the remainder is 0, then it is called as even number. If this condition is satisfied, then print as even number. Otherwise, don't do anything. Let's do one more example. It's very simple. Multiply a given number with 5 if it is an even number. So what to do? First get a number, check whether it is even number or not. So this is the condition to check whether a number is even number or not. If the number is even, then only multiply the number with 5. If the number is not even number, don't multiply. Okay, finally print the value. So for this program, let's observe some inputs and outputs. If I give a value as 4, what is the output? What is the output? As 4 is divisible with 2, the condition is satisfied and the value of a is multiplied with 5 and it becomes 20 and the output is 20. If the given input is 5, as 5 is not divisible by 2 and this part of the code will not be executed and it will give the value as only 5 and it will not multiply with 5. And similarly, if the value of a is 11, what will be the output? As 11 is not even number, as 11 is not divisible with 2 and this statement will not be executed, you will get just 11 as the output. This is the way how this simple if statement works. It's very simple. So what it will do is, it will evaluate expression. If it becomes true, then specified instruction will execute. Otherwise, those instructions will not be executed. That's it. If it is a true, do this. Otherwise, don't do this. So this is simple if statement. Then go with the if else statement. So when we use this if else statement, the if else statement will be used when you have two options and if you want to choose only one among them. For example, you have two vehicles, bike and car. Which one will you choose? It depends on the weather. If the weather is rainy, generally you go with car. Otherwise, you go with bike. Okay? In the same way, so if you have two options and if you want to choose only one among them, then go with the if else statement. Here also, so this is syntax. If the expression, the compiler will evaluate the expression. If the expression is true, the statements in a block will be executed. If the expression is false, the statements in else block will be executed and then the remaining statement just below the if else will be executed. Okay, so this is the syntax. If the expression is true, it will execute the set of statements in if block. So this statement. Okay, so after that it will skip else part and the remaining statement will be executed in your program. If the condition is false, so what it will do? It will not execute this block of statement. It will execute the block of statement you specified in else block. And after that, it will execute the remaining statement after the if else. So let's discuss some examples, different examples. Check whether a number is divisible by n or not. When you can say a number is divisible by n? For example, let us say a. How to check whether a is divisible by n or not? Okay, a is said to be divisible by n only if the remainder is 0 when it is divided by n. Okay, so a is divisible by n only if the remainder is 0 when it is divided by n. Okay, so first get the number, check whether the number is divisible by n or not. If the number is divisible by n, then print as divisible by n. If it is not divisible by n, print not divisible by n. Discuss another example. Check whether a number is even number or not. Get a number. Check whether a number is even number or not. We already discussed what is an even number. So if it is divisible by 2, then it's an even number. Otherwise, it is an odd number. Let's discuss one more example. Check whether a given year is a leap year or not. What is a leap year? A year is said to be a leap year if it is divisible by either 4, if it is divisible by either 4 or it is divisible by 400. Either it should be divisible by 4 or it should be divisible by 400. But it should not be divisible by 100. This year is called as leap year. I repeat once again. A year is said to be leap year if it is divisible by 4 or 400 but not 100. Okay, let's write program for this one. So here we have 3 conditions. Okay, we have 3 conditions. So this is an example for using composite expression. Get a year. Okay, to say it as a leap year, either it has to be divisible with 400 or divisible with 4. So this is R. But it should not be divisible with 100. So if this condition satisfies, then only you print it as a leap year. Otherwise, print it as a non-leap year. Let's take an example. The year as 420. Let's check whether it is a leap year or not. Okay. So the first condition is either it has to divisible with 4 or 400. So it is divisible with 4. Divisible with 4. And one more condition is it is not supposed to be divisible by 100. 420 is not divisible by 100. Okay, so it is a leap year. So 420 is an example of leap year. Then the third one, the third statement in conditional flow, the else if ladder. Okay, so generally we prefer this one. So when you have more than 2 options and if you want to choose only one among them. Okay, so for example, you have 3 options, 3 bikes like TVS XL, Bajaj Platina and Yamaha FZ. Assume that you have 3 options, TVS XL, Bajaj Platina and Yamaha FZ. So which one will you choose when you are purchasing your vehicle? It depends on certain parameters. If cost is your concern, go with TVS XL. If mileage is your concern, go with Bajaj Platina. Okay, if cost and mileage it doesn't matter, then you can go with the Yamaha FZ. So you have 3 options, you want to choose only one among them. In the same way, if you have, when you are writing the program, if you have multiple options and if you want to choose only one among them, then go with the else if ladder. Okay? If the condition 1 is satisfied, the statement in block 1 will be executed and the statement after the else if ladder will be executed. If the first condition is not satisfied, it will check whether the second condition satisfies or not. If the first condition is not satisfied, then only it will check whether it satisfies the second condition or not. If the second condition satisfies, then the statements in block 2 will be executed and then it will exit the else if ladder and then it will execute the remaining statements after the else if ladder. Okay, so like this you can add any number of conditions. Okay, if you want to execute some set of statements when no condition is satisfied. Okay, if you want to execute some set of statement when no condition is satisfied, then you have to specify those statements in the else block. Okay, so if condition 1 is satisfied, then statements in block 1 will be executed and the remaining blocks will be skipped and then the statement just below the if else ladder will be executed. If the condition 1 is not satisfied, then only it will go for this second condition. Okay, the second condition is also, if the second condition is true, then the statements in block 2 will be executed and so on. So you can add any number of conditions. Okay, if you want to specify some instruction that has to be executed when no condition is satisfied, then you can go with the else block. Okay, so this is simple example that make use of else if ladder. Okay, so this here what we are doing is we are going to design an arithmetic calculator which performs basic arithmetic operations like addition, subtraction, multiplication and division. So for that one you need three inputs, two operands n1 and n2, and you need an operator, okay, to perform on those operands. So you need three inputs, okay, two operands and one operator. What compiler will do is it will check whether the given operator is a plus. If the given operator is plus, the statement in this block will be executed, okay, which is nothing but adding n1 and n2. If the given operator is not plus, then it will check for the next condition, okay, minus. If the given operator is minus, okay, it subtract n2 from n1 and the remaining blocks will be skipped and the statement just after the else if block will be executed. Similarly, if the operator is star multiplication, this block will be executed. If the operator is division, this block will be executed. If the operator does not match with any of these four, then this block will be executed, which will print invalid operator. Okay, so there are five blocks: block 1, block 2, block 3, block 4 and block 5. There are 5 blocks in else if ladder. At any time, only one block will be executed. Okay, never ever two blocks will execute at a time. Okay, it can be either first block or second block or third block or fourth block or fifth block. At any given time, only one block will be executed and that is based on the given condition. Switch statement. Okay, the switch statement is similar to else if ladder. If you want to compare an expression with more integer values, more number of options are there, then generally we choose switch statement. The way it works is similar to else if block. Okay, so what it will do is it will have an expression. It will have an expression here. The compiler will evaluate this expression and that result, here the result is not true or false, like if else, else if. Okay, here the result is not true or false. Here the result is an integer. That integer value will be compared with all the labels. So these are called as labels: constant 1, constant 2 and so on. Unlike if else, else if, the value of expression does not evaluate to true or false. It is an integer. It is an integer constant. Integer constant. These integer constant will be matched against all the labels. Label 1, label 2 and so on. You can have any number of labels. Only the instructions inside the matching label will be executed and the remaining statement will not be executed. If no label is matched, then the statements in default label, the statements under default label will be executed. Okay, if it matches with the label 1, then statement in case 1 will be executed and the remaining statement will be skipped. After that, the statement just below this switch case will be executed. If it is matches with the second label, then the statements under second label will be executed and the remaining statement will be skipped. Then the statement just below the switch case will be executed. Here, you have to be very careful when using switch cases. At the end of every switch case, at the end of every case, you are supposed to place the break. What happens if you don't place a break statement? That I will explain you. So this is the same example that we discussed as part of LCF ladder. Okay, it takes 3 inputs, 2 operands, 1 operator. It will check the operator. If the operand is equal to plus, then the statement under the plus label will be executed, and then immediately after there is a break statement. So what this break statement will do is, it will make the compiler to come out of the switch case. Okay, after executing the statement under plus, the remaining labels will be skipped. It is possible because of the break statement. If the given operator is matches with the plus label, then this statement will be executed. If the given operator is matches with the minus label, this statement will be executed. And if it is not matched with any label, then the instruction you specified in the default block will be executed. Let's take an example. If the input is, if n1 is 5 and n2 is 7, and if the operator is plus, so what happens? So what compiler will do is, the compiler will take this operator and it matches with all the available labels. So the operator is matching the first label itself, and this statement will be executed, and you will get the output as 5 plus 7, 12. So after executing this statement, there is a break statement. Okay, it will come out of the switch case. It will skip the remaining labels, the break statement. What happens if there is no break statement? So let us say an example. Let's same example. Let us say n1 is equal to 5, n2 is equal to 7, and operator is plus. So let's see what happens if there is no break statement. So what it will do is, it will take these 3 as inputs. Now it takes operator as plus. The plus is matched against all the labels. The plus is matching with the first label itself. The instruction in label 1 will be, in the first label will be executed, which print the output as 12.0. Why it is 12.0? Because the format specifier is 0.1 LF. It's a float format, 12.0. As there is no break statement here, then all the remaining statement will also be executed. All the remaining labels will also be executed, and the output becomes 5 minus 7 minus 2.0, 5 into 7, 35.0, 5 divided by 7, 0.0. Okay? Even though you are given operator as plus, it executes all the labels. It is because of missing break statement. Okay? For example, if you give n1 value as 10, n2 value as 15, and operator as multiplication. So what happens? Okay? So the compiler will check this operator with all the case labels. Star is not matching with the first label. Okay, these statements will be skipped. Star is not matching with the second label. These statements will be skipped. Star is matching with third label, and these statements will be executed. Okay, the output will be, for now the output will be 10 into 5, 10 into 15, 150.0. As there is no break statement, all the remaining labels also will be executed. Okay, you will give your output as 10 divided by 15, 0.0, as well as invalid operand. Invalid operand. All the remaining statement will be executed. All the remaining labels will be executed. So don't forget to place break statement. Okay, if you don't play break statement, okay, once it matches with any label, and all these labels after that will be executed one after another. Okay, there are some things you need to remember when you are in switch case. In switch case, the value of expression should always be an integer constant. Okay, you are not supposed to give any float, such kind of things. If you want, you can give a character also, because the character again becomes an integer, an ASCII representation, with the help of ASCII representation. Okay, in switch case, the only thing you can do is either you can give integer or character. Okay, if you give a character, again that character will be converted as an integer, and that will be matched with the labels. Okay, so only data types allowed inside switch is integer or a character, and there should not be any duplicate labels. Okay, otherwise the compiler will confuse which one to choose. And the default statement is not mandatory, it's an optional one. If you want, you can add it, otherwise you can leave it. The default statement will execute if it is not matching with any labels. So these are some of the problems on conditional flows. So if you want, you can practice it. Let's discuss one example, the last one. The last one is for the given 5 subjects. For the given 5 subject marks, you have to give the final grade. Okay, you will be given 5 subject marks like 50, 60, 40, 70 and 80. You will be given 5 subject marks and you have to give the grade. The grade should be one among A, B, C, D, E, F, not all. Okay, so how will you do this? What you have to do is, first from the given marks you have to find out the average. Okay, the average is nothing but like 50 plus 60 plus 50 plus 60 plus 70 plus 80 average divided by 5. Find the average. Okay, if average is greater than 90, if average is greater than 90, print A. Else, if average is greater than 80, print B. So like this you can solve these kind of problems. Okay, so these are some of the examples that you can practice.